1. Introduction. In an earlier chapter, we studied a method of deciding whether an argument form of sentential logic is valid or invalid, the method of truth tables. Although this method is infallible when applied correctly, in many instances it can be tedious. For example, if an argument form involves 5 distinct atomic formulas A, P, Q, R, S, T, then the associated truth table contains 32 rows. Indeed, every additional atomic formula doubles the size of the associated truth table. This makes the truth table method impractical in many cases, unless one has access to a computer. Even then, due to the doubling phenomena, there are argument forms that even a very fast mainframe computer cannot solve, at least in a reasonable amount of time, say, less than 100 years. Another shortcoming of the truth table method is that it does not require much in the way of reasoning. It is simply a matter of mechanically following a simple set of directions. Accordingly, this method does not afford much practice in reasoning, either formal or informal. For these 2 reasons, we now examine a second technique for demonstrating the validity of arguments, the method of formal derivation, or simply derivation. Not only is this method less tedious and mechanical than the method of truth tables, it also provides practice in symbolic reasoning. Skill in symbolic reasoning can in turn be transferred to skill in practical reasoning, although the transfer is not direct. By analogy, skill in any game of strategy, say, chess, can be transferred indirectly to skill in general strategy such as war, political or corporate. Of course, chess does not apply directly to any real strategic situation. Constructing a derivation requires more thinking than filling out truth tables. Indeed, in some instances, constructing a derivation demands considerable ingenuity, just like a good combination in chess. Unfortunately, the method of formal derivation has its own shortcoming. Unlike truth tables, which can show both validity and invalidity, derivations can only show validity. If one succeeds in constructing a derivation, then one knows that the corresponding argument is valid. However, if one fails to construct a derivation, it does not mean that the argument is invalid. In the past, humans repeatedly failed to fly. This did not mean that flight was impossible. On the other hand, humans have repeatedly tried to construct perpetual motion machines, and they have failed. Sometimes failure is due to lack of cleverness. Sometimes failure is due to the impossibility of the task.